Gravitational potential, Day 2. Gravitational potential energy. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as the result of the gravitational attraction of the Earth for the object. The value for Earth's gravity is 9.8 meters per second squared. Different planets will have different values of gravity. Generally, the acceleration of gravity is 9.8 meters per second squared, but as we increase altitude or the distance between the Earth and the object, the force or influence of gravity will decrease. This is most noticeable in the upper layers of the atmosphere, where we begin to lose the effects of gravity and start to sense weightlessness. This type of energy has been harnessed to perform work. An example of this is when a child jumps onto a seesaw and can launch another child or object. As you can see in this diagram of the Earth, the black arrows depict the general direction of gravity. The force or influence of gravity begins to diminish after each red circle. Factors of gravitational potential energy. The planet's force of gravity, height or altitude play a major factor. Mass of the object. Air resistance is not a factor. The influence of gravity decreases the further away from the surface of the planet. The higher an object is from the ground, the more time gravity will have to accelerate it and of course increase its velocity. The more mass the object contains, it can provide more potential energy. Gravitational potential energy. Left white lenticular bracket PE, right white lenticular bracket _G equals mgh. As noted before, PEG is a type of energy. This means the units will be in joules. When it comes to mass, the standard unit will be the kilogram. Gravity, we assume generally on Earth, is 9.8 meters per second squared. Then for height we have meters. Relationship between gravitational and kinetic. When objects that are held above ground level are released, they enter free fall. During free fall, the objects are under the influence of gravity. Gravity is a force which leads to acceleration. There will be some cases where the object is thrown. When objects are thrown, we have an initial velocity. This means that there is already kinetic energy involved. If the object is thrown from a height that is above ground level, it is safe to assume that we have gravitational potential energy as well. For scenarios such as these, we need to compute both kinetic and gravitational energy separate and then add our final products. Transfer of energy. Key equals, left white lenticular bracket PE, right white lenticular bracket _G 1, fraction / 2 mv2 equals mgh. Before U, there is a balanced equation. Generally, such as an example of a roller coaster, we focus on one system or object. This usually means we have the same mass of both sides of the equation. We are able to compute the velocity of an object from its respective height due to the fact that energy will be converted from gravitational to kinetic energy.